Okay, so in our topic 8, probability, so we have a few of skill that you should know. So like tree diagram, Venn diagram, formula, table. So all these represent of our information we have to understand. So how we use tree diagram. So we go through first, yeah. So when we use tree diagram, so in you can see in our topic 8, you don't have subtopic. Just under this topic, you must able to find out your outcome, find out your sample space, find out your events, find out your probability loss, and then how to find your probability of an event or conditional probability or intersection union. So independent case, mutually exclusive case, so that will be your outcome in this topic. So it will all together. Okay. So for the first part first, we analyze when we use our tree diagram. So that when they're given us a situation of the experiment, questions talking about your experiment, your activity. So when we're going to use our tree diagram, so that will be one technique of analyzing our situation. So when we're using this, normally it involving phases, okay, ataupun aktiviti awak per peringkat. So means that like you have to take one ball from one box and then go to another box and continue. So it is like phase by phase, level by level activity. One activity continue by another activity, continue by another activity. So when you have this kind of situation and you meet a situation, your experiment is in phases, your experiment is in peringkat, then it will be more easier for us to represent our probability in tree diagram. So you can see overall outcomes. What is that? Okay, so it will not be a single phase only. So it should be more than two or three. Okay, normally we'll have two or three situation, two or three phases to do that. To come to this tree diagram. Okay, so sometimes sometimes we will use Venn diagram. Okay, so how we going to analyze our question and put it in Venn diagram? So Venn diagram, of course, it will not become a phases. Maybe just one general cases. Then maybe have same kind of data, same kind of situation, same kind of categories. Okay, so for the difference between Venn diagram and table is table, it will be two categories. So you can see same kind still means one category like gender. So in Venn diagram you can put in their set, whether it is a girl or it is a boy. So what I give you an example here, a girl and boy should not be this situation. A girl and boy will be our special case, mutually exclusive, where you don't have intersection. So I give you maybe the subject that you like, okay, mathematics or physics or chemistry or bio. So it is a one kind of the things we analyze, the experiment that we do is like in same kind of the things. Okay, so when come to table, it will have two category because when we analyze our table, it will be row and column. So this here will be one category. Maybe your subject, just now what we say, or maybe here it is our gender. We divide by girls or boys. What kind of category that you want. So this one in column, it will be gender. So you can see there will be two type of category of the information involving in this table. So Venn diagram one kind. So in the operation or in the experiment, which is per peringkat, we would normally will analyze using tree diagram. Okay, so that will be our technique of answer, three types. Okay, so what is our general formula? So when we're talking about probability, we must know our formula. So general formula that you should know is when we're doing your probability of an event. So probability in the bracket event. So that event we represent by A. So if you have different notation, you have to stick out. So A here means our event. So probability of an event is should be uh, more than 0 and less than 1. So when we have probability saying 0 means it is definitely not going to occur because probability is talking about chances. When you have probability which is equals to 1, means that your case will be having 100% of occurring. So our probability will be in between 0 and 1. So normally will come to decimal. So if you give a decimal, you also can give in fraction or you can give in decimal. So when you give in decimal, make sure you have to be more than 3 significant. Okay, so you can give your answer in fraction or decimal. So decimal more than 3 significant figure. Okay, so depends. Normally we have 4 decimal place, give more. Okay, so that will be our general knowledge on probability. So when you calculate your probability get negative, that will be nonsense already. When your probability get more than value of 1, that will be also nonsense. Then you know you are not answering correctly. So our probability answer in this topic, uh, our answer most of the time is between 0 and 1. So in general, probability of an event, how we going to calculate means the chances of one event, how we going to get it. So it will be the number of an event divided by its number of sample space. So means number of sample space here, uh, we call it total of the case. So number of event is the things that specialize that you want. Okay, and then that will be our basic probability formula. So ini bilangan kejadian, ini jumlah keseluruhan situasinya. Then what we will have general formula where we want to find a probability for A union B. Okay, so for A union B we can use formula where which is PA plus PB minus PA intercept B. Means you're going to find your probability of A plus your probability of B, and you're going to minus their intersection. So this one, U means union, or you can see or. Okay, N means intersection in our set, or in the other words is N. So whether O and N is very important. So this one is probability A or B. So this is probability A and B. So N means intersection, O means union. So their symbol of mathematics is different. Okay, so that is general. So the complement of one situation, like you don't want to get A. So how you going to find you don't want to get A? Probability of you don't want to get A. We can use complementary 1 minus probability of A. You can get your probability of not A. So this is like common knowledge that you should know. That will be your basics. So of course in this level you have extra one part which is conditional probability. When we come to conditional probability, which is probability of A given B. So its formula will be probability of A intersect with B over probability of B. So this is our formula, conditional probability. So how we know the situation, this question is conditional probability. How we going to read this? So this is how we read probability of A given B. So this is our keyword given. So this is mean by the stroke here, A stroke B. So probability A given B. Sometimes it's not necessarily given, or it can give you a keyword like if it is known that then it's known that, or if. So that is the keyword that we have to alert, or based on probability A, based on B, given that is more common, it is known that also more also common. So if and based on this is like a bit hidden information. So probability A given B, probability A is known. That means something is happen first. Your B is happen first, then followed by your A. So that's why it call it conditional probability. Probability of A given B. So something happen. We want to see based on something already happened. How we get. So we can use this apply to your result. Let's say based on same one mathematic result. So find the probability you get A in this SEM. Based on, so you got something happen first. So here we have two event, but B will happen first. So this is how we write our probability. Find your probability to get A based on what is already happened. So in tree diagram, means B is going to happen first. B is going to happen first, then going to get A. So these branches is probability of uh, A given B. So normally your tree diagram will be uh, space by space, like B you go and A or not A. So here is the place of probability A given B. Okay, so the whole outcome is probability B and A. This is the whole outcome, probability B and not A. So the whole branches proses keseluruhan intersection B and not A. Okay, intersection. But if you refer to this part only, this value only is A given B. So we will see more we will see more clearly when we have complicated questions, because you will have branches, then you will know intersect and given is difference. So that will be our conditional probability. Then we go for our uh, when we have, I have touched out here, when we have Venn diagram. So I also need to remind your syllabus, your basic in your SPM, where inside here is a situation where you have A intersect B. Here is a probability, or in the case of A, the number of, normally Venn diagram we use the number, okay, the number of A intersect B. So if for this part only bulan sabit ini. So let's say this is our set A, this is our set B, okay. So for this bulan sabit sahaja. So kalau bulan sabit ini saja ialah this is the number of B, then intersect with not A. So this is the basic things you should know. So for bulan sabit merah, bulan sabit A sini, ini adalah the number of value A intersect with not B. So different place, different location will represent different situation. So of course the whole here, this is common. This is A union B. So that will be our basic in your SPM. How to see union, how you see intersection. So we go for some special case in our topic 8. We will deal with some special case. Okay, so the special case we will dealing will be, the first one is about mutually exclusive. So unless the question tell you this is mutually exclusive case or not, you cannot use their formula. Yeah. So this is our general formula that we deal with our question. But we come to a special case, like they say, this event is a mutually exclusive, means your experiment is a mutually exclusive. What means by that? Means like in your Venn diagram, your cases will be separate. A and B will be separate. So this is our normal. This is our normal cases, but this is our special case, mutually exclusive. They don't have intersection. So mutually exclusive, the most highlight thing is we know that their intersection will be zero. So therefore when we go for its Venn diagram, it won't have their intersection part here. So it will do the set A and set B separately. So that will be our mutually exclusive. So when we come to their intersection is 0, so what they will affect this formula. So we will put here 0. So when you want to find your A union B, it's just PA plus BB minus 0. So mutually exclusive, we can see on its Venn diagram. You can see their Venn diagram are difference drawing, and their formula, their main idea is talking about their intersection is 0. So another special case is talking about independent. So this uh, part ini dengan part ini adalah bahagian silibus matrikulasi lah. So yang sebelum itu adalah basic, your SPM basic. Okay, another special case is about independent event. So dalam independent event you cannot analyze from Venn diagram. Normally we'll analyze on tree diagram. Okay, so independent event, the most idea is talking about their intersect. Both event intersect, they will be equally A times B. So when you have independent case, then only we can apply this concept. You take the probability A times with its probability B to represent its A intersect. So without the situation of independent, you cannot use that. So you still need to find out where's the place their intersection. You have to find out what's your B intersect A. Find out from your tree diagram one by one. And then because of your intersection is the product of multiplying event A and event B, so it will affect our conditional probability result here. So from our conditional probability result, A given B, supposedly here is A intersect B over PB. So because of the characteristic of the independent, this part, it can be represented by PA intersect PB because of independent event. So you'll notice that you will get back to the result of probability A. Okay, so that will be our analyzing. So for mutually exclusive, kita boleh tengok dari Venn diagram dengan formula dia. So independent event dua bahagian, sama ada kita tengok daripada hasil intersection ataupun daripada hasil given condition. So like what's mean by independent, apa yang bermaksudnya bertikari. So kalau you kena berkandung, because this is A given B, A based on B. So kalau you berkandung kepada B, of course you punya probability tak akan balik kepada nilai A. So kalau you independent, A dengan B adalah independent. So masing-masing punya tak ada sangkut apa-apa lah, maksudnya independent. So saya nak cari probability A, so dia boleh directly get back to probability A. So without the event of B come and affect their probability result. So that will be independent. Okay, so for Venn diagram, right? Untuk sini kan, so tak semestinya kita ini basically hafal lah, sebab 3 ni memang biasa, dengan union memang biasa, intersect dengan union memang biasa. Cuma bahagian bulan sabit sini awak tak biasa lagi, itu adalah B intersect not A. So selain daripada keadaan ini, apa-apa keadaan yang dia nak kita union ataupun dia nak kita intersect, kita sebenarnya boleh lakar sendiri, you sendiri boleh lakar untuk mendapatkan bahagian tersebut. So itu is not a big problem you're going to memorize or what. So what do you need to memorize is their formula. Be careful of the keywords, and you have to understand this special case. Okay.